Hello everyone and welcome to the Danfoss Rethink Live coffee chat session around the topic of walk-in coolers and freezers. My name is Chris Gangemi and I am the Regional Segment Marketing Manager for Danfoss in North America, located in Baltimore, Maryland. I have here with me via video chat my longtime colleague and friend, Gustavo Luna. Hey Gustavo, how are you? And would you like to say a few words to the audience before we start off here?
Hey, Chris, good to have you here. Absolutely, man. Yeah, as you mentioned, my name is Gustavo Luna. I'm the key account manager for Danfoss, currently responsible for the wholesaler channel in North America and Canada. I'm right here seated in the beautiful city of San Antonio, and very excited for, let's say, to be here with you today and chat about walk-in coolers and freezers with you.
Perfect. And since I called you about having a coffee today, I went out today and got myself a cappuccino without sugar, but how about you?
Now I have my coffee. It's a decaf, 2 of sugar, a little bit of milk because I like sweet coffee in that sense. So, yeah, cheers, man.
Cheers, awesome. All right, Gustavo, I think that maybe it's now time that we start talking about the topic that I called you about today. So just a quick note to our viewers out there, please feel free to take part in our dialogue and type your questions into the Q&A box below that's provided by On24, and we'll do our best to answer them either after the session or afterwards. So Gustavo, to begin, I thought maybe we'd just take a step back and briefly talk about what refrigeration is and why it's so important to our lives.
I believe that will be a great start for our topic. Yeah, please go ahead, enlighten me.
Not sure I could teach you so much, but let me see if I can, maybe I'll teach you something. So refrigeration is required for maintaining a proper unbroken cold chain. For example, I'm going to talk about cows and milking the cows. So once a cow is milked, her milk is pasteurized, and it's pasteurized at a very high temperature. Then it's quickly chilled at to a low temperature by some special refrigeration equipment. And once it's at that low temperature, it must maintain that low temperature from that dairy all the way to the grocery store until we buy it. So if that cold chain is ever broken at any place for a period of time, fungus can grow, bacteria can grow, and guess what will happen? We'll get sick. Or we'll at least potentially get sick. So one of the most popular types of business-owned refrigeration systems, amongst others, is the cold room. So cold rooms are one of those pieces of equipment that we may not necessarily see, but they're definitely out there in our communities that we live in and visit frequently. They're installed in restaurants, in hotels, the hotels with restaurants, supermarkets, convenience stores, and basically any place that needs to store fresh, frozen, or pre-cooled food products. Cold rooms, or I actually like to call them walk-in coolers and freezers, are often, they're often referred to as walk-in coolers and freezers in the industry, are enclosed refrigeration storage spaces with doors, so you can walk into them, that's hence the word walk-in, and have a footprint generally less than 3,000 square feet. If you think about it, it's pretty big. That's 50 by 50 if it's a square. And there are refrigerator temperatures around 32 degrees Fahrenheit for refrigerators and below 32 degrees F for freezers. So Gustavo, would you like to add anything to this?
Yeah, I mean, I think that's a great definition, or let's say, beginning for this topic. Most likely, I could just add that I will maybe say that the cold room, is used for a medium, term cold storage. I mean, talking about this cold chain, the cold rooms are in the middle of that chain. With the smaller refrigerator, they use it as a short-term storage, and large warehouses acting as a long-term storage in that sense. Just like in any refrigeration system, the cold rooms, they components, or they have one evaporator inside, or one or more evaporators inside the room, and they use a condenser and a compressor on the outside to move the heat outside of the room that you are trying to cool down. So most likely a walk-in, let's say a cooler, typically it's used to maintain food and beverage, while a walk-in freezer, it is used to keep, freezing or frozen food in the restaurants or in any application that you may have in there. Normally that product in the freezer comes already frozen to the walk-in that you are talking about.
Perfect. I really appreciate you explaining that. Sure. I would also perhaps maybe add just a couple things. First of all, most times the walk-in is field erected on site, and it's actually shipped in pieces. And you'll find that the refrigeration is shipped along with the panels and the doors. And once it gets to the site, it's typically installed indoors. Then, of course, a licensed electrician and refrigeration technician are hired to complete the installation and start it for the first time. But there's also sometimes that there's manufacturers that'll make the walk-in at their facility and pre-assemble it along with the refrigeration system, put it on a flatbed, and then that truck will drive down the road and deliver it to the place where it'll be installed, typically outdoors. And even in these installations, you may not even know it's there because it'll be designed and to match the existing structure. Even if the structure has bricks on it, the walk-in will have bricks on it, or it'll be painted the same color. So you may not even know it's there. In some of these outdoor installations, the walk-in may be installed inside maybe a hole in the wall of the building, and they call it a through wall. And in that case, it's very, very nice because the owner or the user of the walk-in doesn't actually need to go outside to access his goods. He could stay in his building, open the door, and go into his walk-in that's installed outdoors. So hopefully this brief introduction made things a bit clearer. So Gustavo, do you know if all walk-ins are constructed the same way?
Well, actually, that's an excellent question from you, Chris. I can probably divide them, from a refrigeration perspective, the refrigeration system perspective, and broadly speaking, there will be three kinds of cold rooms that we can talk about by refrigeration system. The first one, it will be the self-contained, let's say, walk-in coolers rooms. The second one, it will be remote condensing units, and the third one, it will be what we call probably multiplex. If we talk about the self-contained rooms, most likely, as the name implies, is a kind of a package or a snap-on unit, similar to those AC window units that you have, everything in one small cube right there. That will be probably similar to the one that you may use on these self-contained cold rooms. Most likely, you will have like an opening on one of the sides of one of the walls of the walk-in cooler, or an opening on the roof or the ceiling of the walk-in cooler. So you're gonna snap on the unit right there, and air will be starting to flow inside the room, cooling down or making the effect of cooling down whatever you have inside the room. If we talk about the remote condensing units, as the name implies as well, that means you have two separated, let's say, not system, but the parts separated. Basically, you will have the evaporator unit inside the room, which is the one in charge of blowing the cold air in there, and you have the condensing unit, which is the one that dissipates the heat towards the environment. You will have that installed in the side of the building or in the side of the cold room, depending if it is a through wall or it is inside the building. Maybe sometimes you will have that condensing unit seated on the roof of the building, trying to make sure noise and heat, let's say waste, is not going inside again into the restaurant or the store or wherever you have this cold room. The third one, they call it multiplex, most likely is tied up to multiple compressors. It's like a centralized type of system where you have a room or a building room dedicated to the condenser portion of the refrigeration system, and then you just run lines that it goes to probably one or more, let's say, different cold rooms in there, similar to what you will call like a rack system in a supermarket.
Oh, perfect. That's very interesting. So this multiplex ones, those are the ones we find in supermarkets, right?
Yes, that's what I say. Yes.
So are there any other considerations besides the refrigeration system when you refer to the construction of a walk-in?
Well, yes. I mean, there is many considerations you will have. I mean, being the refrigeration system, the heart of the walk-in cooler, you will not be probably having a walk-in if you don't have a properly enclosed space, right? That space is most likely made out of insulated walls. Those, insulated walls could be walls, ceiling, and sometimes the floor as well. Those are made out of, some type of foam that it is, probably sandwiched, if you want to call it like that, between two plates of either aluminum or light steel in there. The better insulation you have, the better conservation of the temperature you may have inside the room, right? This is another factor. It plays a key role into the efficiency for that, walk-in cooler or freezer that you're talking about. Um, in addition to that, I mean, talking specifically for the floors of the walk-in cooler, those needs to be reinforced in order to support all the heavy load or all the product that you're gonna be putting inside the cold room, right? And there is also some other features that you can put in there in the cold room about the door or about the closing, for that specific area that you are cooling down. Normally, the typical door is made as well of foam, is sandwiched with a couple of pieces of steel or aluminum that it can be just open and closed depending on how the traffic it wants to go inside the room. But there are some other kind of a little bit more efficient to walk type of doors that you can offer in the walk-ins. One of them being, the plastic strip curtains. Sorry, most likely what a plastic strip curtain makes is gives an easy access for a high traffic type of rooms in there. You can go inside, in and out, and those plastic curtains will maintain the temperature or maintain the cold inside the room and not letting it leave towards the restaurant or so. Another let's say type or another option you may have on the door is to have some blowers that it blows air at high velocity from top down, and that flow of air at high velocity is making like a stop for the cold to keep inside the room and not going outside of the cold room, allowing as well to make it more efficient to go in and go out from that. I mean, you can see probably some of those in stores on supermarkets where you have the dairy product in an open space that it is probably refrigerated, that you can go in and out, and it will not be sensing that difference of temperature in the outside than the inside. So both designs, it helps to keep the temperature of the cold room low, and it works as well, for having a good efficiency of that room, Chris.
Perfect. It's the introduction made things a lot clearer for me. It also made me a little bit hungry to talk about sandwiches, but maybe we'll have a sandwich when we're done. So, based on your engineering background, would you mind giving me a brief summary of the main components used in the refrigeration system, and also maybe perhaps are they any different than say the components that are installed in a self-contained cooler or freezer?
Yeah, of course, Chris. Well, I can tell you, let's say in a refrigeration system, there is four main components. One being the compressor, the second one being the condenser. Then you have the metering device or expansion device, and then you have the evaporators. Of course, a refrigerant needs to be circulating inside, that hermetic system where it's interconnected all these components. Typically right now in the market we're using 404 steel, but customers are switching more and more to a lower GWP type of refrigerants, such as the 4488. You probably will know a little bit more and talk us about it. But the compressor and the condenser are often supplied as a one part or one assembly. And it's most likely, the high pressure, high temperature portion of the refrigeration system on the condensing unit, using pretty much any type of refrigeration system, including the walk-in coolers and freezers. It can be probably offered from the manufacturers in a different kind of type of assemblies. Some of them it could be bare bones, and some of them just like the Danfoss offers, it could be fully loaded with all the different pre-installed controls that you may need to control, let's say, properly a refrigeration system on a cold room, such as filter dryer, such as side glasses, dual pressure controls, maybe some of the fan speed controllers, some of the receiver tanks, or even some of them have as well a service valve that allows you to service them pretty easily. Um, the metering device is kind of very important as well because it's the one that, let's say, controls how much refrigerant is flowing into the evaporator, making sure it let's say, keeps a constant cooling flowing through the evaporator. The evaporator per se is the one that is blowing that cold that the refrigerant through the metering device is bringing, and it's making that blowing into the cold room per itself. Normally, that evaporator is connected to a high velocity fans that makes the circulation of the air a little bit more easily in there. Of course, you have to take into consideration as well how you load that room. I mean, make sure the racks you have inside has some openings for the air to keep flowing inside the room. Also, one last but not least, I want to mention as well, within the controls, you need to, have some type of temperature controller. It could be a mechanical thermostat, or it could be probably an electronic thermostat. So in that sense, you will be having a good temperature reading inside the room. And I can tell you, I could continue talking about, the physical part of the walk-in cooler, some advantages and disadvantages on the different types. But, let's try to explore different aspects of the walk-in cooler market. And I will give you the word, Chris, so you can share your thoughts on what's currently happening on the North American market.
I thought you might ask about that. So glad that you asked. So as you can imagine, there are lots of changes that have been implemented at both the federal and state levels that affect the walk-in market, and especially the ones equipped with remote condensing units. Maybe I'll just briefly talk about a few that I'm familiar with. As you may have heard, the U.S. Department of Energy passed energy standards for walk-in coolers and freezers that were enforced for new installations beginning in 2020. If I remember right, in January was for refrigerators, and in middle of the year, I think in June of 2020 is when the enforcement was implemented for freezers. So this new energy efficiency is called the annual walk-in efficiency factor, or you hear people call it AWEF, AWEF. So AWEF is the ratio of heat removed from the cooler or freezer to the total energy input to the refrigerator over a 1-year period. And this efficiency standard is applicable to walk-in coolers and freezers that are less than 3,000 square feet. So it excludes any of the refrigerated warehouses. And there's some exclusions, maybe 3 or 4 exclusions. And one particular that I remember, it excludes any walk-in that's specifically designed for scientific, medical, or research. So you don't have to worry about if you're building walk-ins in those for those industries. So in short, the manufacturer of the equipment, such as Danfoss, must test and meet or exceed that minimum AWEF in order for their equipment to be able to be installed in a walk-in in North America. There's lots of information about the testing standard and AWEF on the DOE website. In fact, there's a proposal to update the test procedure and determine a more stringent AWEF can be achieved. So if you're interested, maybe you could take this up in another chat down the line, and or you could just take a look at some information that's on the DOE website. You may have also heard that the U.S. Environmental Protection Agency, or the EPA, has passed the American Innovation and Manufacturing Act, or AIM Act, as you may commonly hear it. In it, there's a phase down of the HFC refrigerants used across the industry, including walk-ins. So when we talk about the HFC refrigerants, it's of course the fluid that's circulated throughout the refrigeration system, but it's also used in the foam blowing equipment used in the walk-in panels. So the phase down of the refrigerants, of these kinds of refrigerants, is a schedule that's very much like that of the Kigali Amendment, that is a amendment to the Montreal Protocol. So interesting enough, Canada has ratified this amendment, but the U.S. has not yet. The phase down that I mentioned earlier with the AIM Act has already started in 2022 with a 10% reduction from the established baseline. And the next big step down will be in 2024 with a 40% reduction versus the baseline. And the step downs will continue over the next few years, all the way to 2036, when we finally reach a 15% of the established baseline. As you can imagine, the availability and the costing of the traditional HFC refrigerants used in the industry will go up, and the industry will be forced to approve alternatives that are more environmentally friendly. You mentioned R448A earlier, and that is an alternative that is currently being used. So we don't have the time to go into all the details of the proposals that are being put onto the EPA, but for sure there's going to be a shift to non-HFC refrigerants that are also have a low global warming potential. So in general, I think it's a good idea to keep track of the proposals that are being made to the EPA via their website, and it's organizations such as AHRI and the California Air Resources Board are making proposals that may end up as laws. Some are granted already, and they may end up laws in the coming years. So besides these two major agencies, there has been some states that have taken matters into their own hands and have actually adopted, for example, adopted SNAP Rule 20 and 21. But SNAP Rule 20 is very, very important. And maybe I should step back. So SNAP Rule 20 was previously vacated by the U.S. District Courts and is not allowed to be put into law. But some states have adopted that SNAP Rule, and the SNAP Rule is important because it has delisted the use of R404A in remote condensed units. So today, you cannot ship a condensed unit charged with R404A to certain states in the nation, such as California.
Wow, that's it seems like a lot of information, Chris, and I bet it is a lot of information about the regulations and so on. But I was just thinking about this annual energy efficiency for the walk-ins. Is that AWEF requirement only applicable for United States?
No, actually, I'm glad you asked. I think I forgot to mention that the AWEF requirement for the U.S. is similar to that for Canada. In Canada, there's an organization called National Resources Canada, or NRCan, and that organization has almost the same requirements as the U.S. for AWEF. One of the differences is that the certifications must be done by a third party, while the DOE allows for companies such as Danfoss to self-certify their equipment.
No, that sounds good. No, that's a great overview about the regulations, Chris. So yeah, what do you think we should talk now?
Well, there's a couple of things I was thinking about, but one in particular, everything around us is on the internet. We hear about this IoT, Internet of Things. Is that even applicable to our industry? Is there anything that's relevant to, say, refrigeration, in particular walk-in and coolers and freezers, that maybe you could talk about a little bit?
Yeah, that's true. I mean, it's a very interesting topic, besides the regulations. So, Internet of Things, or IoT, it's pretty much used in every industry right now. And I can tell you, the walk-in coolers and freezers of this cold room market is not away from that. I mean, there is let's say some concept that you're probably in Danfoss we call like smart store, that includes some of these connections to the walk-in coolers. It's basically, let's say, using your smart devices to connect to the walk-in coolers and freezers and understand what is happening. And this one, I can tell you, is becomingly more and more important every day. And many users and store owners and maintenance chiefs, they are looking, for solutions that comes normally, for the walk-in coolers or freezers. And let me just give you an example about this. I mean, or just point yourself. Let's imagine that you are the owner of a good restaurant, one of the famous restaurants, and you have your cold room inside the restaurant, and you have a lot of let's say big giant shrimps in there, and some marlin fillets in there that you need to store in a proper temperature so you can sell it to your customers, right? What may happen if at some point that cold room breaks in during the night and you don't realize it until you get there next day to the restaurant? You will probably feel a bad smell of food starting to spoil, and that investment that you have in there on the food, it will probably have to be wasted. So we're talking about not just the cost for to repair the cooler, but the cost for the spoilage that you have in there. If you have like a connected cold room or a smart cold room that it can connect or send you alarms directly to your mobile phone or to your smart device, or that it can connect probably to a cloud where you can analyze data and get the alarms from that end, probably if that cold room breaks during the night, during, let's say, probably the next hour or a couple of hours, you may have someone already going there and try to fix what is going wrong with that cold room, and that avoids a lot of spoilers. And it's not just the cost for you, but you can imagine, the cost that it may happen across the whole cold chain on that end. So with the connectivity used to monitoring, let's say those temperatures or those consumptions of the compressor or the condensing unit or the evaporator, it may make let's say less costly any repair that you may have in there for that specific cold room, right? Typically, as well, I can tell you in the market, several different manufacturers, they're already working on their own solution. Let's say manufacturers as a Danfoss, they can offer you some solutions for connecting your cold room into the an alarm system that it can get push notifications into your mobile phone or your cloud or whatever system that you have in there. Even though if you are like a contractor, you can probably offer to the store owners where you are selling a new cold room right there, the option to monitor for them that cold room and act fast if something happens with that cold room, right? So this is developing still. I mean, there is some solutions. Some others are more advanced than others. It's in a different paces today for the different manufacturers. But I can tell you, connectivity, it will be the future, and a lot of suppliers will have a solution to offer you into the market. So it's a great thing to have, that to have coming into the let's say this market as well, the cold rooms and walk-ins, Chris.
Wow, that's really, I had no idea. I'm glad I asked that question, and it's very important, obviously, to protect our equipment and protect the assets inside there. As you mentioned, you don't want to walk into your store, into your restaurant, and find spoiled shrimps and whatnot. So.
Yeah.
I'm really glad that we had the opportunity to speak today about the walk-in coolers and freezers.
Same here.
Yeah, appreciate it. But before we wrap up, it looks like there might be a couple questions that were sent in previously. So let me just take a look at these and see if we could provide an answer. So the first one says, as a contractor, how do I know if the parts I am buying are qualified to use in a walk-in? So I think I could probably take this one. This is along the lines of the DOE requirements. So first of all, your equipment needs to meet the minimum AWEF requirement, and I think that's the question. So the equipment itself may have on the label may say that it's designed and certified for use in a walk-in cooler or walk-in freezer or both. If it's not there, you may want to check the manufacturer's literature. So if you know that exact model number, go ahead and look up the literature on your smartphone, and then the AWEF number will be listed there, and it should also mention that it's qualified to be used in a walk-in. If those two things are too hard, the third one is obviously DOE maintains a database. They call it their Compliance Certification Management System, or CCMS. So if you Google CCMS, you'll find a link to the equipment that is certified. You can download that list and make sure that the model number of the refrigeration condensing unit or evaporator is listed. So we have another question here, and it says, I understand that the AIM Act will drive up the cost of high GWP refrigerants. What refrigerants should I consider to future-proof my system? So yeah, this is kind of it's a difficult question to ask, but of course you could design your system with CO2, which has a 0 GWP. And it's actually that refrigerant, which is considered, it's called R744. It's SNAP approved for use in a remote condensing unit for walk-ins. But beyond that, I'll really be speculating as to what the EPA and the industry will approve down the road. So, but there's clearly a drive towards using lower GWP refrigerants, and some of these low GWP refrigerants, say below 200 or 150, are slightly flammable. So we call them A2Ls. So I think we just need to wait and see a little bit longer about which refrigerants will be SNAP approved for walk-in coolers and freezers, and remote condensing units. So it looks like there's a third question, Gustavo, and it says, will the AIM Act override the different refrigerant requirements that are at the state level, like Carb? So when they mention Carb, that's the California Air Resources Board. So to answer this question, let me see. So the AIM Act allows for the EPA to address the production and consumption of the HFC refrigerants. But ultimately, at the end of the day, it's up to the state to determine what is right for their state. If their requirements are more stringent, then you'll go by the state level. If they're less stringent than the AIM Act, then of course the federal level will take over. So I think that answers that question.
I see. Good.
So if there's any other questions that are left unanswered in the chat, Gustavo and I will do our best to answer them as soon as possible. So with that, Gustavo, I think we're ready to wrap it up. And I just want to take the opportunity to thank you and everyone else for joining this session. Gustavo, as always, it was a pleasure to talk, and I hope to see you again. And maybe next time we could actually meet over dinner instead of just a coffee.
That's a great idea. I mean, thank you for having me here as well, Chris. And yeah, once we get there to dinner, let's make sure we choose a restaurant with a good working cold room, right?
Sounds good. Have a great afternoon.
Have a great afternoon, you too. Thank you.